How's it going, everyone? Welcome to page one of the final exam review. In chapter one, the first question asks whether or not it's true that Newton's law of gravitation states that the force between two objects is directly proportional to the mass of each. That is true. Remember that the magnitude of the gravitational force between two objects is proportional to the mass of each and inversely proportional to the square of the distance separating their centers of gravity. So if I reword that on the final, I'll probably ask it about the parameter r, not the parameter m. Question two, in terms of Newton's second law, write a sentence or an equation specifying the difference between statics and dynamics. Newton's second law states that a body accelerates when a resultant force is applied to it. As an equation that's written as vector F equals m times a. And a is a vector, of course, as well. And remember that acceleration is just how quickly the velocity of an object is changing. So in statics, a is equal to 0. What that means is that it's either the object itself, since it's not accelerating, is either stationary, it's not moving at all, or it's moving at a constant velocity. The majority of questions that we dealt with in this class, they were just stationary. In the case of dynamics, acceleration is not equal to 0. Question three, true or false? Applying a particle model in static analysis implies that the object being analyzed is small. That is false. All that it means is that we don't actually need to consider the dimensions of the object in order to be able to perform the analysis and get the results that we're interested in. That happens whenever all the lines of actions of the force acting on an object pass through a common point, and that we refer to as a concurrent force system. Question four, write a sentence explaining the meaning of the term rigid body in the context of mechanical analysis. A body is rigid if when forces are applied to it, the deformations or the little changes in its shape are negligible from an analysis point of view. So everything is going to deform slightly, but we can ignore the deformations for purposes of analysis. Question five, convert 1200 megagrams to the appropriate SI units of mass. Remember that mega means 10 to the sixth and that the SI unit of mass is kilogram. So what I'm going to do is I'm going to take that mega and I'm going to divide it up. I'm going to take one factor of 10 to the third and write it with a coefficient. And the other factor of 10 to the third, that's what I'll use for my kilograms. So when I have the 1200 times 10 to the third, that's actually equivalent to, in engineering or scientific notation, 1.2 times 10 to the sixth kilograms. Last question from chapter one. Compute the mass of an object whose weight is 32.2 pounds when we're assuming that the acceleration due to gravity is constant near the surface of the Earth. We can always compute mass as nothing more than the ratio of the magnitude of the weight divided by that gravitational constant. In empirical units, weight, of course, is a force, and the units are in pounds. So 32.2 pounds divided by acceleration due to gravity, 32.2 feet per second squared. If you do that math, it turns out to just be 1, and in empirical units, the units of mass are slugs. So that's it for chapter one, and I'll see you all in chapter two.